Good evening, guys. Today we are solving a medium level problem in Geek4Geeks, and the problem is minimize the difference. So, what this problem first? Let's analyze the problem and what the problem is talking about. So, suppose we are given an array of 1, 2, 3, 4, 5 elements, and the size of the array is say 5, and then we will also be given a value of k in the runtime input, which is 3. So, we have to find and remove sub array of length 3. Say for example, if you remove the array of length 3, that means total 3 elements have to be removed from this particular array. So the array is like 1, 2, 3, 4, 5, and if you remove the first 3 elements, we will be left with 4 and 5. And now what we are going to do is we are going to calculate the difference of the maximum and the minimum element of the remaining array. So the maximum element is 5 and the remaining element is 4. Minimum element is 4. So difference will be 5 minus 4, which is 1, right? So the output will be 1. So the question is we have to remove a sub array of size k. Size k means the total number of elements present in the second array or the sub array inside this array, and we have to difference between the maximum and minimum value is minimized, and we have to find the minimum value obtained after performing the operation of the removal of the subarray and then return it. Let's take another example. Suppose we have 6 and we have k equals to 3. So say for example we take the first subarray, which is 2 3 1. Then the possible combination of the minimum difference will be 4 6 and 7, and 7 minus 4 will be like 3. Suppose we take out the array 314. So basically what we can see is this is using a sliding window technique. In a sliding window technique is first element maximum value, which is given 3, so you have to take 3. So say for example you have say for example if you have three elements present in a sub array out of a main array which is having like say 6 elements, right? So in 6 elements, first 3 elements you are going to iterate and take out the maximum of and the maximum remaining of and then you have to take out the remaining one, right? Say for example you have 2 3 1 4 6 7. First you have to remove the first 3 elements, right? Because in order to check the sliding window technique, it is one index at a time, right? Say for example when you're doing 2 3 1 4 6 7, first 2 3 1 has been executed. In the second execution you can see 3 1 4 has been checked, next 1 4 6. So index by index, total 3 index we have to take. Say for example in the first iteration 2 3 1 will be taken, second 3 1 4, next 1 4 6, and last 4 6 7. So you can see in each case, after taking the 3 elements, whatever element will be remaining, from that we have to take the maximum value and their minimum value, and then we have to calculate the difference. And out of the difference in all possible combinations, we have to return the minimum difference of all the possible combinations. So I will do the problem statement into two parts. First, I will code it right now, and after that, I'm going to explain you the problem statement once more with the coding implementation. So first, we can see this is a say medium level problem uses sliding window technique and DP concepts. So first, what we are going to do is we are going to basically initialize our variables, right? So what variables we can take first, like look at this example and assume what we can do. We are going to take write min and write max arrays, and which are used to store the minimum and the maximum values encountered from the present current index to the right end of the array. So for doing that, what we are going to do is, like say for example we are standing over here which is on 2, and from 2 to the end we are going to find the uh, we are going to find and store the minimum and maximum values which we encounter from the current index to the end of the array, right? So for example what we can do is int write min, it's an array, equals to new int n. I strongly recommend you guys to watch the sliding window techniques from given link I will share in the description box. From there you can understand the concept of sliding window technique. Write max equals to new int n. So this is for elements from current to rightmost and store most minimum element from current to rightmost and store most maximum element. So what write min and write max is basically doing, so for example after removing whatever we are left with, we can see a maximum difference of 7 and a minimum difference of 4, means maximum value of 7 and a minimum value of 4. So in write max we can write 7 will be stored, then again 7, then again 7, and write min you can see what values can be stored, 4 2 2 1, all these values, right? So in all the possible, so both the arrays will have some examples. Say for example in this particular explanation of the example 2, I can write my array as in write max equals to all the values which is there in the maximum areas. So 7 comma 7 comma 7 comma 3, and examples in write min, I can write particular examples 4221 4221. So how this is coming? Because you have to see this explanation where it has said which is the rightmost maximum, which is the rightmost minimum after subtracting the array from the sub array. So for main array, after subtracting the sub array, which is used using sliding window technique, we have to do this. Okay, let's go with the code. Int, now I have to take maximum floating values. So int equals min equals to, this is for the index, max integer dot max underscore value. Int max equals to integer dot min underscore value. Int answer equals to integer dot max underscore value. So carefully understand this thing. Why maximum and minimum dot max, and what are the functions of dot max and dot min? So main is initialized to integer dot max value to track the minimum value encountered during executions, and max is initialized to integer dot min value track the maximum value encountered during iterations. So this is used to track minimum value during iterations, and similarly used to track max value during iterations. Next is the answer is used to store the minimum difference found. Is used to store the minimum difference found. Also, I will teach you a technique. Whenever you are seeing minimum, whenever you have to calculate minimum, what you have to do is integer dot max value. So this is like complementary to each other. If this is minimum, this will be maximum. If this is maximum, this will be minimum. And since answer we have to take and store minimum difference, you again see this thing. The word minimum is present, so we have to use max over here. So don't get confused that why am I using max when I am taking min. No, whenever using min, you have to take the antagonistic or the complementary value of max, like that. Now what we're going to do is we are going to run a loop, okay, and from the right to the left at each index, and we have to update the right max and the right min to store the minimum and maximum values encountered. So we have to make a loop right now which will iterate from right to left. So what is right to left? So 0 1 2 4 6 7 7, right? So right is like n, right? So from right to left, so for int I equals to n minus 2, I less than equals to 0, I minus minus. So I can write over here loop from right to left. We have to traversing. What is traversing? Means searching. Traversing means searching. So traversing loop from right to left. So what we have to see is from right to left is from 7 6 4 1 3 2, like that. Okay, we have to traverse. Now we have to store the rightmost max value from right to left, the rightmost max value and rightmost min value in this particular right max and right min array which we have created in line number 68 and 69. So what we are going to do is right min of I equals to math dot minimum, because we have to take minimum difference here of I, which is the present element, current element, and the rightmost I plus 1. Right max equals to math dot max. Similarly, here of I is just the same concept. You can see for max, I will use math dot max for finding the maximum value present from current element to the rightmost element. And for minimum value, we are using math dot min for taking the minimum value between two elements found adjacent to each other from the present value to the rightmost value. So rightmost value to the present value, right? Because the loop is running from the right to the left. And right max of I plus 1. Same logic, but one we will use mat.max, and for max we will mat.max, and for min we will use mat.min. So what basically we are doing is, for at each index I, we are updating the right min and the right max value to store the minimum and maximum values encountered from index I to the end of the array. Now what we are going to do is, we are going to close this loop. Yeah, for loop. So what this from right to left, to store from pair of I to right most which value is minimum, to store from pair of I to rightmost which value is maximum. Now we are going to explain the sliding window technique after this. So I can write sliding window technique continues. I'm giving the comments in order to make this answer more easier for the students who are watching it for the first time, or who are performing sliding window for the first time. Say for example, we will take an I0 and j equals to k minus 1. So while I am taking j equals to k minus 1, so for example, in the let us consider examples, right? Because right now I don't have the, I can't afford an iPad in order to explain you diagrammatically. So I'm trying my best to explain you through some examples. I'm trying my best to explain you through some comments and through some examples, right? So for example, in the particular array which has 2 3 1 is the sub array for the first time, and again 3 4 1 will be the sub array, and again 1 4 6 will be the sub array, and again 4 6 7 will be the sub array. So see, let us write the sub arrays over here. Sub arrays possibilities. What are the possibilities of the sub arrays? 2 comma 3 comma 1, right? Then again the sub array possibility can be, since, and why this is 2 3 1, because we have to take only k equals to 3, means we can only take 3 elements in the sub array, and whenever you can see k is equals to 3, means k has a value of k minus 1 is the length. So for the let me first continue complete the sub arrays. So it will be 3 1 4 in the next sub array, and in the next sliding window. So this is like a window, have you have seen the windows in our hostels, right? When you have to slide, it goes to move to the other side and the fresh air comes. Similarly, we have to slide the element, slide the index, and move from one index value to the another index value. So 314 is done. Similarly, we are going to do is 231 is done, 314 is also done. We are going to do is 231 314 146 1 4 and 6, and next is 467 4 6 and 7. So these are the sub arrays. Now I'm going to give the index. So again the index will be 0 1 2 0 1 2. So you can understand, right? I'm not continuing the other indexes, like over here I'm putting dot dot dot, because these are the indexes. Let me change the orientation. Yeah, indexes over here, 0 1 2 0 1 2, like this. You have to take the indexes, and that's the reason why I have taken the up, I will say upper bound of the array as k minus 1, because k is 3, so 3 minus 1 is 2, and similarly we can see the upper bound is 2, because we have to think in terms of the indices of an array. So that's how the upper bound is done. Next, what we're going to do is we're going to use the sliding window technique. So while j is less than n, so the loop will only run if the upper bound value, which is 2, is lesser than the index of the total number of elements, which is 3, which is 6. So total number of elements is 6, but the sub array, you have to think very clearly that the sub array is a small part of a big array, right? So sub array should have a very index, or the length of the sub array should be lesser than the length of the bigger array. Similarly, so we have to check over here that j is k minus 1, right? So I can easily write over here while k minus 1 less than n, but no, I have to take the upper bound, right? We can't, because whenever we are doing a window also, suppose there are n number of windows, n1 n2 n3 n4, and we are sliding each of the windows, we can only slide if a main frame is big enough to accommodate the small frames, right? So I hope I'm trying my best to explain you why suppose if you have a main frame which is really really big, and you have to have the small frame which are really small frames, the small frames can easily be accommodated inside the main frame. Similarly, that's the reason why the j, or the index of the small arrays which is present inside a large array, has to be lesser than the index of the larger array, right? Now what we are going to do is we are going to check the if condition. If I not equals to 0, not equals to 0, basic if test case, then we have to store the minimum value, math dot min of ARR of I minus 1. So what basically we are going to check, if I is not at the start of the array, we are going to update minimum and maximum by comparing the previous elements and the current min and max. So what are the previous elements? I minus 1 is previous element. Remember it very clearly. That what is I minus 1? Always remember I is one position, so I minus 1 will be the previous element. So math.min of like this, and max equals to math.max of ARR I minus 1 comma max. Okay, so we have clearly stored and calculated the max and min values. Now what we are going to do is we are going to close this if condition, and we're going to take a temporary variable which will store temporarily the value of the max, and temporary variable 2 which will store temporarily the value of the min, because each time the max and min value can be updated, and we have to check copy of the max value obtained, copy of the min value obtained. Over here I can see limit of small array has to be less than limit of big array. I hope this solution helps somebody who needs it. So max, temporary max and min has been stored. Okay. Now we are going to again calculate the temporary values. So temp1 equals to, since temp1 is doing max, so mat dot max of temp1 comma right min. Over here we have to put I plus 1. So let's check once what we have to put. Uh, Sorry, since my inner loop index is j, so I have to take over here j. So mat dot temp2 equals to math dot min of temp2 comma right. I guess I have to take for mat dot max, I have to take the right max, yeah, and for j plus 1. So this is the sub array calculation. Don't confuse it. I'm telling you again and again. When the sliding window is done for what purpose? Over here I should write for sub array. Whatever again I have done over here, right max, right min, this is for the remaining part of the array. So like if you have, suppose if I have a train and the initial AC coaches are removed and sleeper or non-AC coaches are left, that sleeper or non-AC coaches, which value have the highest value from the sleeper or non-AC coaches, we have to find using the sliding window technique. So sliding window technique is used for the smaller bounds, not for the upper bounds. So temporary variables, we have to take mat.max for sliding windows of the initial values, right? So temp 1 and 2 have been clearly done. Now we're going to store the answer, which is the minimum difference obtained from the possible combinations. So math.min answer will be math dot absolute of temp 1 minus temp 2. Now you will ask me, why am I using, give me a second. Now you will ask me, why am I using temp 1 minus temp 2? Temp 1 minus temp 2 is basically giving me the absolute difference in the sub array present, which is 7, which is like, I have to carefully think, right? So the sub array I'm taking as 2, 3, 1, right? And 4, 6, 7. So in 4, 6, 7, the difference I'm calculating temp 1 minus temp 2. Very clearly you have to understand this particular thing. And right max and right min, don't get confused, everything I've mentioned. So similarly, I will also put a comment over here in order to understand this thing. Calculate temporary minimum and minimum based and the right minimum and maximum values, and answer with minimum of its current value and the absolute difference. And lastly, what we are going to do is the absolute difference, the answer. We are going to slide the window. We have to slide the window, right? So we have to slide the window. We have to return the answer, and we have to close all the loops. So I have to check whether the loop is closed. Yes. While loop is also have to be checked. Yes. I not equals to 0. Checked. Checked. Everything has to be precisely checked before returning a particular answer. So I missed a statement if that j should also not be equals to the limit, right? So like the way I put I condition, I have to also put a condition for j, and that condition has to be placed while calculating the max of temp and min. So if j not equals to n minus 1, so j not equals to n minus 1, then I have to store and calculate the answer after calculating. Similarly, I plus plus, j plus plus, and we have to increment, and let's execute. I know this is a long problem because it's a medium section problem, and what it is saying, write most which is maximum, not a statement, write max 82. So in 82, maybe I haven't used uh, the semicolon properly. This, this. Correctly calculated. What is the problem? Write max, write max, write max equals to error of I. So write min I have to use. Yes. Now let's compile. So you have to be very precise with what you write. You have to be giving like attention to detail. Math.max is not a statement. Math.max is also we have to check. So this is over here. Yes, we are closing over here. Right max equals to error of I and comma right max of I plus 1. What it is saying is not a statement. Math.max. Hmm, why is it not a statement? Right max of. Oh, see, I missed the I inside this bracket. You have to be very, very precise with what you code. One simple thing can ruin the entire code. What again is the error? J less than illegal start of expression. If I not equals to 0. So maybe I have to put, have to check if I not equals to 0. What is the problem? Illegal start of statement. It shouldn't be a problem. And where error not a statement where j less than n, while because I've taken the j values. Oh, I haven't put a comma over here and messed up the entire thing because we are initializing two values at the same time. What it is? Limit of the cell j line number 10 90 j is, so I have to check where did I close the j loop. Yes, the j loop is closed correctly. High is also closed. If I not equals to 0, illegal start, what can be there? If int I0, we have taken j as k minus 1, j has to be less than n, j has to be less than n, right? What is the problem? We have taken the limits as well. If condition is also there. If I not equals to 0. Um, what is the problem actually? I haven't seen a problem like this. J not equals to n minus 1 is not a problem. But if I not equals to 0, yeah, I have to check whether I is not equals to 0. Why it is not a illegal start of statement? Hmm, what is the problem? If I not equals to 0, I have to ask the yogi. Sometimes the AI bot helps because right now my brain is. There was pointing two lines. If the so the syntax, check the opening and closing parentheses and make sure they are placed. Also, pay attention to special characters that might opening and parenthesis, closing parenthesis is also placed correctly, right? Yeah, we've correctly placed the opening and closing parentheses as well. So what is the problem? If I put this thing which I haven't put over here, let's compile. So this comments obviously interfere sometimes. You see the expected output is working. Let's submit our particular problem. Oops. Possibly occur multiple test cases. First test case where your test case failed is both failed. Output difference is 2. Now what is the problem? Again, I must have some problems. Let's check. So if I'm minimum maximum done, temp 1 equals to min, temp 2 equals to max, and temp 2 equals to temp 1 equals to min, temp 2 equals to Let's calculate. This is really irritating. Let's fix the error. Sometimes this is becoming very tiresome to submit the code. I have to. mm, because probably I missed some comma, semicolon, or stupid thing like that. Because my code should work perfectly. But still, I will execute it once more in order to be precise. So where is that? So we have completed, say, 60 what days? I'm going to 62 days on the GFG platform, and this problem was a medium problem, and we have successfully solved this problem correctly. We have total score has also increased by a lot of margin because it's a medium problem, and you can see it has 33% accuracy rate as well. And I hope you understood this particular problem. Whatever the error is, I have to check again and tell. But I've completed the entire program. It's basically the same. So yeah, hope you enjoyed this problem solving, and hoping to see you next time. Thank you, Tata. You upload.